Hello and welcome to Statistics for Business 1. I'm Shankar and I'm your instructor for the course. We were talking about percentiles.
I'm Liza and my IQ is at the 99th percentile.
She's quite modest usually. Well, I hope by now you understand what percentiles are. If not, I will suggest that you go back to our earlier coverage of the material. And Liza, you may be at the 99th percentile, but do you know that there are 12 million more Indians at your IQ level? And that's assuming that Indians are like anyone else on the planet.
Alright, you win.
All of what we have been discussing applies to numerical variables. Remember the gas prices that we downloaded from the World Bank website? Now, to describe a numerical variable, we would not only use summary measures such as mean and deviation, we'd also like to know how the values are distributed.
Alright, how about a histogram?
Sure, once we draw up that histogram, we'd like to perhaps slice it up into equal portions. That's where percentiles come in handy. Let's pull up the percentiles that we've already calculated for our gas prices. Notice how we've chosen them at quarterly intervals. We call those values as quartiles. So the 25th percentile is the first quartile or Q1. The 50th percentile is the second quartile or Q2. And the 75th percentile is the third quartile or Q3. Mind you, these are not equidistant. Q1 and Q2 are about 30 cents apart, whereas Q2 and Q3 differ by a good 36 cents.
What's the 0th percentile? What about the 100th?
All good questions, Liza. Well, you might have guessed that these are the extreme values of our data set. The 0th percentile is the minimum and the 100th percentile is the maximum.
I wish there was some way to visualize all of this.
Absolutely, Liza. It's called a box plot. First, we put the values of the numeric variable on a line. Next, we build a box using the three quartiles. Q1 and Q3 make up the left and right edges of the box, and we draw a band at Q2, which is nothing but the median. Now, the difference between the third and the first quartile is the width of the box. We call it IQR or interquartile range. In our case, the IQR is Q3 minus Q1 or 1.77 minus 1.11, which is about 0.66 or 66 cents. Now, the dotted lines to the left and to the right of the box are called whiskers. What these whiskers extend to is a matter of choice.
I didn't know such things happened with stats.
There are some situations in statistics where we must make a call and stand by it. This is one of them. An American mathematician called Tukey came up with this version of a box plot. The whiskers stop either at the extreme values or at a fixed distance of 1.5 IQRs from this box, whichever comes first.
1.5 IQRs amounts to $1.
That's convenient, isn't it?
What about those dots on the left?
I'm glad you spotted them. You can see they lie beyond the 1.5 IQR mark, which is one way to qualify what are known as outliers. We'll talk about other ways later on when we cover the normal distribution.
You mean even the idea of outliers is subjective?
Absolutely. But we can't be reckless about it. We must clearly state how we identify our outliers. Look carefully at our box plot. The left side of the median band has a shorter width than the right. What would you make of it?
They both pack 25% of the data, but it's a more relaxed packing on the right.
Well, Liza, what if the histogram was symmetric?
Then the median is really in the middle of the box.
That's right. You would be tempted to say there is a skew towards the right or a positive skew. We fully know that this isn't so. The skew is in fact negative at minus 0.41. This is because of the left whisker, which in some sense counterbalances that positive effect. We have an exercise for you built around just this idea. Also, as an exercise, I will ask you to go ahead and identify outliers for the other years in our data set.
You mean for 2008 and 2010?
Yes, and I have used R to come up with a single plot for all of these 3 years.
The outliers are in the upward direction.
One last point. A close look at these box plots tells us that the median price for a liter of gasoline at the pump has generally moved up across the world and over the years.
And so have the maximum values. I smell inflation.
Right now the prices are dropping. The times they are changing, as Bob Dylan would say. We know that the choice of bin size can alter the way a histogram appears. These two histograms are for the same data. Not so with box plots. That's an advantage. Box plots are often used to get a quick idea of containments in a data set where the individual data points can confuse even the best among us. An advanced platform like R allows us to put a histogram and the corresponding box plot together. You can think of dropping those verticals to get a better idea of containment. We've given our percentiles a visual feel with box plots. We've now come to the end of the segment. All I can say is that we have to exercise caution with drawing our conclusions. If we have a skewed data set, then carrying out basic arithmetic operations like taking the midpoint of two quartiles can be hazardous. We have a bunch of exercises around all of this. I hope you enjoy the learning.
Go box with those plots. Bye bye.
That's right. I'll see you later.